Okay, Assalamualaikum and good morning. Right. Okay, how are you today? I hope you are feeling well and you can do necessary preparation for your quiz next week. Okay, let's continue where we stopped last week. Yeah, we have tutorial 2 on SPDF notation last week. We stopped there, and today we're going to continue with orbital diagram. Right? Okay. Say that you have a question that asks you to write the orbital diagram for nitrogen. Okay, how do you draw the orbital diagram? First, you write the symbol, excuse me. Yeah, you write the symbol of that element, okay, that represents the nucleus, and it will be very useful if you can show the proton number as well, which indicates the number of electrons, yeah, if the element is neutral. Now, next, as usual, yeah, you show the orbitals. Yeah, to show the orbitals, you can use dashes like this. Okay, this is for 1s, and then you have 2s and 2p. Of course, it will be very useful if you can write the SPDF notation first, yeah, before you write the orbital diagram. What's the SPDF notation for nitrogen? Okay, if you write the SPDF notation, it will be 1s2, yeah, 2s2, and 2p3. Now, these dashes here, yeah, represents orbitals. Yeah, represents orbitals. Now, okay, we have 7 electrons. So first, just like Aufbau principle, we fill the first 2 in the first orbital, that is 1s. The arrows must be half-headed. Okay, 1, 2, 3, 4. Okay, now, when it comes to degenerate orbitals, yeah, orbitals like P and D, we call them degenerate orbitals. We apply Hund's rule or Hund's rule. No problem. There's no oral test in chemistry. Yeah, the electrons are filled with parallel spin first. Yeah, so 1, 2. Yeah, 1, 2, 3, 4, 5, 6, 7. Yeah, you don't fill the electrons like this. Yeah, 1, 2, 3, 4, 5, 6, 7. No, this is not right. So you fill the orbitals singly first, yeah, before they are paired. And that's it. This is the orbital diagram for nitrogen. Oh, okay, I don't like dashes, madam. Okay, fine, you can use boxes. Okay, which is, I think, clearer, but more time consuming. If you think you can manage to draw the boxes in your exam, I have no problem at all. Yeah. So 1, 2, 3, 4, 5, 6, and 7. Okay, as you can see, the orbitals are combined together, indicating they have the same energy. Yeah, that is the meaning of degenerate. Right. Okay. Now, knowing how to draw the orbital diagram, okay, we have, you can do all the exercises. And one more is on anomalous cases for chromium and copper. Okay, as I mentioned before, degenerate orbitals, yeah, are orbitals with equivalent energy, same energy. When I say equivalent, it means setara, setara, equivalent energy. And one characteristic of degenerate orbitals is the orbitals are more stable when it is half filled okay, or completely filled compared with when they are partially filled. Okay, degenerate orbitals are like P, yeah, P, D. Now, when half filled, that means P, there are 3 electrons in P, half. For D, there are 5 electrons in D, and full, completely filled, when there are 6 in P, 1, 2, 3, 4, 5, 6. And for D, instead of 5, we have, okay, if they are all full, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half P3 and D5. For full or completely filled, it is P6 or D10. Right? So for chromium, the proton number is 24. If you draw the orbital diagram, you will get something like this. Oops, sorry. 1s, 2s, 2p, 3s, 3p, 4s, or you can rearrange, no problem. 4s and 3d. Okay, so 24. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. 8, 9, 10. Wait. I cannot write. 8. Hold on. Okay. Where is my pen? Right. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So you see, this is the expected orbital diagram from the Aufbau principle, from the normal way of writing. However, knowing the characteristic, in this case, it needs one more to achieve the extra stability of 3d5. Therefore, rearrangement will happen in which one electron from the 4s will rearrange to 3d and becomes 3d5, to gain or to achieve that extra stability. So in this case, this is the expected configuration is this one here, but the actual will be the whole thing. Okay, same thing here. 1s, 2s, 2p, 3s, 3p, 4s, and 3d. Same thing just like before. The only difference is just here. Okay, sorry. So this one in 4s, there's only one left, in which the other one has rearranged to 3d orbital and becomes 4s1 and 3d5. Okay, and for the reason, I want you to try it yourself and try for copper.